little shaky with the solubility rules, what you should do is write them down a whole bunch of times before the test. And when you get the test, write them down on the test. So that way you can kind of forget about it. It'll get it into your short term, but eventually you want it into your longer term memory. Anybody have them memorized? Almost? Oh, this is good. You're definitely going to be asked solubility rules. For the reactions, though, we're going to just focus on these reactions here. Like for redox, we're only going to do one type. The element plus element yields compound. The compound breaks down to the element. For metathesis, we'll have the double replacement style reactions. For acid base, we'll have the Bronsted. Normally, if the metathesis fails, then you try the acid base. You get no reaction. Just want to make sure. Okay, there's not going to be any redox out of this, so we're not going to do combustion. We're not going to do single replacement. We'll have those for the next step. That means the homework is mixed up. The homework is going to be mixed up because the book introduces single replacement reactions early. And so what I want to do is take a look at some of the homework problems here. For the homework, since the chapters 8 and 9 have single replacement intermixed with the other reactions, what we'll do for chapters 8 and 9, I'm going to collect the homework with the next test complete, rather than a partial assignment this time. Since we're not having double replacement reactions, you don't need to have that homework done for this particular test.
Homework then for chapter 10?
10 is not going to be on this. Okay. Yeah. Yeah, chapter 5, 6, and 7, I'd like to do a complete homework assignment. Chapters 8 and 9, you should do the homework, but you don't have to do all of it. So if we take a look at chapter 8 homework, the first part of chapter 8 is just balancing reactions. This is just balancing. So even though this reaction is this is a single replacement reaction, or no, this is element plus element. Element plus element. Element lithium, element oxygen yields lithium oxide. Element plus element. This is just balancing because they tell you what forms lithium oxide. So all you need to do is write the correct formulas and balance it. So let's take a look at the homework assignment here. So 17911, 11 boron combines with oxygen, form diboron. Diboron traps.
Are we going to go over the test review?
Well, this is kind of the test review right now.
But like the exam you posted?
Yeah. We'll go through that.
Okay.
So 1 through 11 so far. Okay, 13. Aluminum combines with bromine to form aluminum bromide. That's okay too. 15. Pure hydrogen iodide decomposes spontaneously to its element. It's a redox reaction. Okay, 17. Barium peroxide breaks down into barium oxide and oxygen. So here they're telling you what the products are. You just have to know what the formulas are. 19. Calcium reacts with hydrobromic acid. Now this one, they're not telling you what the products are. You're supposed to predict the products in this particular case. We can predict the products by knowing that this is single replacement. Should have just had single replacement on here because that's the only thing missing from chapters 8 and 9. Single replacement. But it's A plus BX pattern, so you have to figure it out. So this one is not due for this exam. So number 19, you don't have to do it for this test. Maybe you already did it. These single replacements aren't that difficult as long as they work. That is, as long as they're not one of the exceptions. So 19, don't bother. 21 single replacement, don't bother with that. Write these down if you want. 19 and 21, you don't have to study those. 23 you have to study because 23 is not single replacement. Do you know what type of reaction 23 is? Double replacement. 25, double replacement. 27, double replacement. So double replacements we're going to have. So you should study those. 29, double replacement. 31, double replacement. 33 is a combustion reaction. Well, morning class didn't want combustion reactions. Although combustion reaction is pretty easy because it's this, in this case butane, plus oxygen yields what? Carbon dioxide and water.
But it does require mixed fractions.
This one, it might require fractions, it might not. Depends on the steps you take here. This is more of a balancing and writing out the formulas because they tell you what the products are. So, here. This one for me would have required fractions. Because I would have done it like this. I would have done 4 carbons and then got 4 CO2s. And 10 hydrogens, got 5 waters. And then add it up. 4 times 2 is 8 plus 5 is 13. So to get an odd number, I'd have to go 13 halves. Then I'd multiply. That's the way I would have balanced it. But, this is a combustion reaction in which you don't have to predict the product, you just have to balance it. Balancing is part of this test. So you should know how to balance this. You should be able to write the formula for carbon dioxide, water, and oxygen. But I'm not going to ask you to predict the products. 33, 35. Sulfurous acid decomposes spontaneously to sulfur dioxide and water. That one you're supposed to have memorized because that's, where did we see that reaction? Sulfurous acid, where did we see that reaction? Hey, that was one of the driving forces for metathesis. Do you have the driving forces for metathesis down in your memory, or are they still very fuzzy? Really fuzzy? That's not good because this is the day before the test. Metathesis you should review every day. What are the driving forces? Precipitation. So you're going to know the solubility rules. group 1 and ammonium are both soluble, et cetera, et cetera.
I thought they were like, if you have a precipitate, a stronger acid changes to a weaker acid.
Yeah, stronger acid to weaker acid is the next one. There it's a little easier because you could use the acid chart. And what was the last driving force?
Gas.
Gas formation. What were the gas formers? H2CO3, NH4OH, and there's more than this, but H2S. HCN is another one. H2S. H2S is another one, and H2S. Complete it for me. H2S. Not O4. H2SO3. H2SO3 is called.
Sulfurous.
When sulfurous acid decomposes into sulfur dioxide, aqueous or gas? Gas.
So these are unstable.
It's unstable. This already should have been. Well, this is what you're going to find as you continue in the sciences. Is you're going to find there are some students. There are some students who, ever since they can remember, maybe ever since in kindergarten, they've wanted to be some surgeon or some medical doctor, and they're going to do whatever it takes to get into medical school. And those students always set the curve. They set the curve. They're always on top of it. They ask them. Then it's like right off. Because let me tell you, at UCSB, when I was a teaching assistant at UCSB, there's a lecture, Chem 1A lecture. Chem 1A lecture, there were about 300 students there. And they did surveys, just show of hands, how many of you are pre-med? And out of 300 students, I'd say 70% of them raised their hand. 70% of those students wanted to go to medical school. The reality is, how many of those are going to make it? How many of those students are going to make it into medical school? Very few. So it's a very small percentage. And so, it's good to have ambitious goals, but in order to do that, you got to be on top of it. And those students are on top of it, the ones who are going to go to medical school. So if you want to do that, you got to at least try not to cram everything in the night before or the day before. Just try to build up to it. Like solubility rules, you don't want to cram that in, and then you don't want to memorize. What were the other gas formers? Well, carbonic acid decomposes into what? Carbon dioxide and water. Sulfurous acid decomposes into sulfur dioxide and water. Ammonium hydroxide decomposes into ammonium, water. Ammonia I wrote as AQ or gas. The same thing with sulfur dioxide. Right, AQ or gas. Then there's HCN, hydrogen cyanide gas. H2S, hydrogen sulfide gas. So this one, even though this is an acid-base type reaction, and it's related to metathesis. It's one of the driving forces for metathesis. 37, calcium reacts with water. Okay, calcium reacts with water. This is single replacement, so skip it. 37. 39, zinc metal is placed in silver chlorate solution. Skip that. It's single replacement. 41, ammonium sulfide is added to a solution of copper 2 nitrate. That's double replacement. We studied that. 41. 43, phosphorus tribromide is produced when phosphorus reacts with bromine. That's element plus element combination. 45, when calcium hydroxide is heated and forms slate, forms calcium oxide and lime and water vapor. This one is a acid-base reaction, but there's a difference. There's a difference between having to predict what the products are, predicting the chemical properties versus just having to write the formulas. This is, there's no prediction involved here. All you have to do is write the formula for calcium hydroxide, calcium oxide, and water. And so, calcium hydroxide, calcium oxide, and water. And balance it. The types of things that you won't have where you have to predict, like this one, you have to predict what happens. Chlorine gas combines with solid potassium. No, okay. No. Silver nitrate. The ones that you don't have to worry about are the ones that you have to predict the products of solid phase. 47. This one's glycerin reacts with oxygen to form carbon dioxide and water. So we just write the formulas and balance it. 49. Antimony ignites. Okay, this is element plus element, but they tell us the product, so I might not tell you the product. 51. A solution of potassium hydroxide reacts with a solution of zinc chloride. Double replacement. 53. Solid ammonium chromate, dichromate decomposes. This is just writing out the formulas. 59. Sulfuric acid is produced when sulfur trioxide reacts with water. This is also an acid-base reaction, but this one we didn't cover. It's not one of the types we covered. This is just a lot of practice writing out formulas. 61 and balancing. It's not a lot of practice predicting products. 61, a solid oxide of iron, Fe3O4, and hydrogen are the products of the reaction between iron and steam. I'll talk about this. This is a very unusual compound in a way for nomenclature. Aluminum carbide reacts with water to form aluminum hydroxide and methane. 65. Magnesium nitride and hydrogen are the products. So most of these reactions, they tell you what the reactants are and they tell you what the products are. All you have to do is balance them, making sure you have the correct formulas. 69. 69A, here we have to figure out what the products are. This is an extra level of difficulty because we have to figure out the products and then balance it, figure out if there's a driving force or no driving force. But A, what type of reaction is that? Single, so ignore it. B, double, so do it. C is a combustion, but you probably already know. What are the products of combustion? Carbon dioxide and water. So I asked if people wanted combustion this morning. They didn't want it, so just ignore it for this. You're going to get it in the next test. Combustion. D, what type of reaction is that? So double, so do that. E. We're probably doing a decomposition type reaction. You know, the compound breaks into the elements. So this would just form elemental lithium and elemental bromine. That's what I assume they're doing there. Let's see if that's the case. Yeah. However, they should put the states here. Lithium bromide is normally in the pure form, what? Solid. It's a solid salt. It's a soluble salt, so if there's water around, it would be aqueous, but it doesn't say if there's water around. And there would be no water around because we need high temperature to do this. So it's going to form lithium, which should be a solid, and bromine. Bromine, you know, bromine is weird. Because bromine is not like chlorine and fluorine. Chlorine and fluorine are gases. Bromine is a liquid. It's an element that's actually a liquid, like mercury. There aren't that many liquid elements. And iodine is a solid. F. What type of reaction is that? Double, so do that. G. It's a redox, element plus element. Should yield calcium chloride. H. H is a single replacement, skip it. I. Double replacement, do it. J. Single, skip it. That's 69. That's 71. 71 is acid base, but I think in this acid base they tell you, So this is just more practice writing out the formulas and balancing. They tell you the reactants and they tell you the products, so you don't have to predict. I want chapter. Chapter 9. Chapter 9. Write the major species in solution. This is just electrolyte properties, solubility, and electrolyte properties. So that's fine. You're gonna have those on the test. So 5, 7, 9, 11. 17. Solution of potassium nitrate in solid precipitated silver phosphate form. 17 is double replacement. 19. 19 is what? Single replacement. It is an NR, but it's single replacement, so it's not going to be on this test. 21. What type of reaction is 21? Single replacement, not on this test. Next test. 23. Single replacement, skip it. 25. 25 is different. This is chapter 9. So in chapter 9, they aren't going to tell you when it's burned. They aren't telling you it's reacting with oxygen to form CO2 and water. They're asking you to figure it out. When it's burned, you'll have to figure it's butane plus O2 yields CO2 and water. So you don't have to worry about this type because this is predicting the products. So if I throw in a combustion in there, it's just writing the formulas and balancing it. 27. Ethanol is oxidized. That is predicting the product. So 27, we'll skip it. What type of reaction is that? Double. Do it. 31. Double, so study that. 33. Double. 35. Double. 37. Double. 39. Double. 41. 41 is metathesis also. 43 metathesis. 45. Double replacement metathesis. 47. Same. 49. Barium chloride and sodium sulfite, double replacement. 51. Iron 3 sulfate and cobalt 2 nitrate, double. 53, double. 55, double. 59, double. 61, single. 61, don't bother. 63, double. 65, double. 67, single. 71, double. 73, single. The single replacements we're not going to worry about. The only type of reaction we're going to predict the products are going to be the double replacement, the element plus element, and then Bronsted. Like I said earlier, Bronsted, you're going to do this if metathesis fails, like we did in bronze. You can just check it for potential Bronsted. Yes.
So we're turning in the homework tomorrow, you just want 5, 6, and then minus of 7?
No, all of 7.
All of 7.
I don't want partial assignments because partial assignments are headache to grade. So I just want the complete assignment with the next test for chapters 8 and chapter 8 and chapter 9. Chapter 10 is not due. We haven't made it that far yet. Okay. That doesn't mean since I'm not collecting it tomorrow. That doesn't mean you don't have to do it. You know. You still have to do it to get the practice. Yeah, in order to see. Yeah, you're just going to turn in 5, 6, and 7. And so what I went through there is which problems do you need to focus on your studies on. Don't waste any time with single replacements. What else do we want? We want nomenclature. You know, if you look at the old exam here, the old exam, this is different because I'm behind schedule this semester. And so it's a little different. This test is going to be a little different than yours. But nomenclature, this is fine. You know, it's the name of the name of the formula of the ions. Those, you know. I'm sorry.
For arsenate.
Arsenate, yeah.
Like what would it be? Like AS? I was kind of confused on that one.
You follow a pattern. What's fluorate look like? Well, I heard it earlier. FO3. What's the charge? Minus. What's chlorate? CL, is it the same or different? ClO3 or ClO4? Chlorate. Bromate. What's phosphate? What's arsenate? Arsenic is right below phosphorus. What do you think arsenate is? ASO4 3 minus. It's arsenate. Arsenate was in the news a couple of years ago, maybe even more than a couple of years, maybe 5 years ago. There's a lake in California, just east of Yosemite, called Mono Lake. Mono Lake doesn't have any fish there. No fish. There are some like shrimp, I think. But the arsenic levels in the lake are very, very high. Arsenic levels are very, very high. There's bacteria growing in the lake. And so a NASA biologist, what is a biologist doing for working for NASA? Do you know what they're doing? They're looking at extraterrestrial life. What types of things are needed for extraterrestrial life. And so one of the things that they proposed was that, because us humans, we're based on phosphate. Have you heard of like ADP and ATP?
Yep.
Adenosine diphosphate and triphosphate. You know what those molecules are for? Those molecules are for energy. And so they're thinking, well, if there's a high arsenic compound, maybe they aren't phosphate based like us. Maybe there's potential for arsenate based life. Arsenate based life instead of phosphate based life. Maybe on other planets there's high concentrations of arsenic, and maybe a whole another branch of life developed not based on ADP, ATP, that type of stuff, but based on ADA, diarsenates and triarsenates. It's like a parallel universe type thing. And so the scientists from NASA tested the bacteria and found the arsenic levels very high in the bacteria. So they got excited and they published an article in Nature, the journal Nature, about arsenic-based life. And so there was a lot of excitement surrounding that, but the excitement died completely. Now it's nothing. Do you know what happened? What they suspect happened? What they suspect happened was that their samples were contaminated. And so what they thought was arsenic coming from within the bacteria actually were external contamination from, the water or whatever else. So there are other things too. There are a lot of skeptics because the arsenic-oxygen bond, the thing that holds the oxygen atoms and the arsenic atoms together, is very weak. So weak that, light, it's like visible light can break it. That wouldn't be a problem as long as they're not exposed to too much light, kind of stuff. But there are a bunch of skepticism. There's a bunch of skepticism regarding that, which there should be because that's a pretty bold scientific development there. And so arsenate, arsenate, we're not going to touch on any arsenic. Arsenic's toxic. We used to have arsenates in our lab, like sodium EDTA. You know what we decided to do with the arsenates in lab? We basically threw them all out. Why? Because we didn't want the students poisoning themselves. Because there are students who are pretty careful, but then there are students who don't know what's going on at all. They might contaminate themselves. So that's why we threw them all out. We used to have a lot of arsenates and leads and that kind of stuff. Anyway, all these arsenic. All these are just memorization. Do you have these memorized, or can you figure them out? Then we have compounds, molecular compounds, salts or ionic compounds, and acids. Then we have a mixed compound. Some nomenclature.
Is that sodium silicon tetroxide?
I'm sorry?
Is that sodium silicon tetroxide?
No. Tetra you only use for tetra is only used for binary molecular compounds. Tetra. Bi is used in multiple ways. Sometimes bi refers to two. Sometimes bi refers to having hydrogen in there, like bicarbonate. Iodine. This is not sodium silicon tetraoxide. You know, I've seen so many names for this. Let me tell you one name, another name I saw for this one last semester. Tetrasodium monosilicon tetroxide. That was not too bad either. Because at least they're keeping consistent. But that's wrong. Yeah. This is sodium silicate. Because we know the silicate ion is SiO4. You guys know what silicate is, right? SiO4